Thank you for coming. This is static sites through single-page applications in GraphQL. I am at Chris Biscardi on Twitter and a couple other places too, generally the same name. I work on design systems and UI platform at Dropbox. If you're familiar with the term design ops, that's effectively what I do. Before that, I built the UI team at Docker. What I'm going to talk about today is going to be a project called Low Earth Orbit, also known as LEO. It's available on GitHub under superawesomelabs/Leo. And it effectively implements a lot of the concepts that I'm going to talk about today. So let's talk about static sites. Today we're going to go over templating, or how you get your markdown files and data into an actual rendered application. We're going to talk about styling, and sort of what works for static sites today in tools like Jekyll and Hugo, and sort of the newer approaches to CSS that are evolving. We're going to talk about the data model that classic static site generators like Jekyll use versus how we might improve on them. We're going to talk a little bit about universal applications and how they are so close to static sites that there's almost no difference. We're going to spend a little time on routing and URL generation. We're probably not going to do too much on progressive web apps, but I'll mention it a couple times. And then finally, I will describe a little more about the structure of the Low Earth Orbit project and how it enables these things. So first, let's talk about templating. Templating is the way that you get the data in your markdown files or whatever into the actual page that you want to render. And typically in classic static site generators, you're using something like a template language. You're using Liquid, you're using Handlebars, you're using maybe Mustache if you don't like the way that Handlebars does things. And the issue with using template languages is they get really messy, they get really complex. They start growing features of general purpose languages. So they start off and they don't have much logic, and then you need an each loop. Maybe you need to capture a variable in one location. So in this example right here is trying to create a breadcrumbs for navigation. And you can see that there's a lot of these sort of curly braces and percent signs, which sort of take over the control flow of the page. And it's kind of hard to see where things are starting and ending. You'll see that instead of declaring a variable or a constant, we are declaring these captures in special blocks. And this sort of grows and grows and grows until you're including these things in others, and it turns into a sort of hard to maintain jungle of spaghetti template code. Luckily, there are a few features of JSX that will help us get rid of some of that complexity. This is a very similar component. You can see that we've used typical JavaScript language features to accomplish what before took special language constructs. So in this breadcrumb, we had to, if there was a URL passed in, loop over that URL and concatenate the link up to the part where we are actually existing, and join them all together with a slash so that we can get a link that is specific to each breadcrumb. In JavaScript, this is sort of easy to write, easy to understand. You get access to things like Lodash, where you can just say, take the next 3 items from the index that I'm mapping over, and you automatically you get the link that you're supposed to get, rather than trying to do operations on an integer to make sure that you get the amount that you want. And moving on from JSX, it's not necessarily tied to React, but it's very often used in React. And if you embed it with a React context, then you get prop types. And when you go to combine your templates, you have a way of specifying how they should be combined and what they need to actually get their job done. Whereas maybe when you're using Liquid, you're using more of a string concatenation approach. Whereas with React, you can get developer warnings if you're not using it correctly. And you can even take this further with TypeScript or Flow, and you can start using stateless functions with much harder types. So in this case, we have a stateless functional component, which can be used in Preact, React, or a number of other libraries. And we have this URL type, which specifies more information about what kind of string we want to accept. And if you use this approach, you get a series of composable functions that are spec'd so that you, at build time, can figure out whether you're passing in the wrong data or not. And it would be really nice to use these when building static sites. So let's talk a little bit about styling. And styling from the very basic approach of just using CSS to the more common approach of using Sass or post-CSS these days. And then we're going to cover a little bit about CSS modules and some of the more interesting approaches that are coming out these days, such as Glamour, or known as CSS and JS. So when you're styling your sites, CSS works, but it gets much hairier as the code base progresses in size and complexity, and even just the number of people working on the project. It's really nice to be able to reuse your design systems on your static sites as well as your applications. You put a lot of work into developing these systems where everything will look consistent and everything will lay out correctly. And if you don't do it in CSS, if you're using, say, React components or something like that, or Angular components, it's sometimes hard to fit that into the world where Jekyll is expecting to render templates. So there are problems with CSS at scale. This is a list of problems that Viju enumerated in the CSS and JS presentation. There's the problem of global namespace. And global namespace is an issue because as soon as you have more than 2 people working on a single project, you get more likelihood that you're going to both write a button class. Systems like BEM exist to manually set up and make sure that these don't conflict, but it's a very manual process. And then there are other issues such as source order dependencies. If you have a CSS rule specified and then you have another CSS rule specified and they both combine to be used on the same div or something like that, the last one written will be the one that applies. And this is a problem if you try to dynamically load CSS and do really anything in advance with your loading of CSS. One of the other things I'll mention on this slide is the sharing of constants, which if you put your CSS into JavaScript, comes for free, much like moving from Liquid to JSX gives you the abilities of the JavaScript language. You have a more general purpose language rather than bolting on language syntax constructs. And then finally, there's the isolation issue, which CSS modules takes one of the approaches of solving. The issue with CSS modules is that you have, if you have, for example, a table row, and you have a button inside of that table row that you want to show and hide based on whether somebody is hovering over it. This is really hard to accomplish with CSS modules if you have these styles in 2 different files. Basically, there's no real good way to import the selector, target it, and modify the styles that should be applied. So if you move to some of the more interesting approaches that are coming out over the last, say, year or so, known as the CSS and JS movement. They started out with inline styles, and a lot of people have a very adverse reaction to inline styles, which is understandable, because you can't use things like media queries, right? But there's a project called Glamour, and this is an example of Glamour syntax that very much tries to replicate the CSS syntax that we used earlier. The problem with using this syntax is that you have to use all three selectors on your class. We get a little bit of deterministic ordering here. If you look at the F1 red rule set declaration, but it's still not great. The other thing that's interesting about Glamour is it's not inline styles. It dynamically adds rule sets to a CSS style sheet in the browser. So it uses natural browser APIs to enable things like media queries. This is sort of a better approach using Glamour, where you can merge these rule sets together, and because you can control the ordering in which they're merged, much like a JavaScript object.assign, essentially, you get to determine which rule sets or which sub-rules are actually applied in the final object. Let's talk a bit about the data model for static sites. Jekyll uses a markdown to page data model, effectively. If you put a markdown file somewhere in a directory, it will result in a HTML page at that location in your URL structure. This is really nice, but things like collections can feel tacked on. Hugo has the concept of data files, where you can put say an array of objects inside of a YAML file, and you can access that data when you go to render the actual site. So what if we just start thinking about our data as data instead of files on a file system? If we separate out our data model, and we think of it as a database, we can effectively think of all of our different content types that sit on the file system, in addition to all of our different content types that sit in different locations like the GitHub API or a GitHub repo or a GitHub branch or something like that. And we can trivially enable more complex integrations. We can do things like use contentful as the source of our data and introspect the type system, or the type system, but we can make REST calls to contentful about the data that is contained in contentful and reflect that in our content database. So if we look at what one of these JSON models looks like, this is a JSON model for a markdown file. Now, this markdown happens to have come from a file, so it has a file property, but it didn't have to. It could have come from an API. It has some markdown attributes, which may have come from the front matter and may have been processed, such as the title, the slug, the URL that it wants to render at. And then we have the raw body and the body, right? So we have the raw markdown in case we want to render this in the browser later, or we have the HTML if we want to render out the static site at build time and not deal with actually sending down a markdown renderer to the browser. And the answer to basically how we would query this database is GraphQL. Show of hands, who's familiar with GraphQL? Sweet. Talk title worked. So if we set up a query for, say, the first 5 markdown files that are in our database, we can then select the fields that we want back and only send those down to the browser later. Since most of you are familiar with GraphQL, I won't go too into that, but I encourage you to look it up if you are not. So the query result for the GraphQL query looks like this. It is the attributes that we selected and the body that we wanted. And the idea here is basically that we turn this data model and interface into a pull instead of a push. So for Jekyll, you are taking these markdown files and the data that it gets processed into and pushing it into templates based on the file directories that you have set up. In this world, we are requesting data from this database through a typed interface, and thus pulling data based on the URL into our React application or any other. This enables a much higher level of flexibility if we depend on the way that we render our app as a function of the URL. And these GraphQL specifications are effectively content types. They are interfaces for the data that we want to render in this static world. And these things can be content types from WordPress, content types from Contentful. They can be markdown files. They can be anything you want them to be, basically. They could be latex if you really want to do that. And if we use these GraphQL schema fragments, content types, to specify the data that we're going to have, we can auto-generate APIs, such as filtering. So in this example, we have some blog posts, and we have a GraphQL query field called all posts. And the way that we get the documents that are not published is we simply filter on published, because we know that GraphQL specified it as a Boolean. We can construct the appropriate filter query. And if you're interested in sort of these automatically generated filtering and sorting, there's a project called graph.cool done by some people out of Berlin that I encourage you to look into. They have auto-generated sorting, auto-generated filtering, and their filtering language gets much more complex than this. Graph.cool. C-O-O-L. Universal apps are effectively static sites in disguise. The only difference between a universal application where you are rendering on the server and the client and a static site is when you do the rendering. So in a static site, we're going to be doing the rendering at build time, and the availability of your data. In a universal application, usually you're doing requests against a database that maybe users are constantly updating. But in a static site, the assumption is that most of your data is going to be fairly set, right? When you do a render, you don't need to update 30 seconds later when somebody else hits the page. So if we talk about universal apps and sort of the code that goes into them, there's four main concepts here. One is that you have to have a render function on the server, and you have to have a render function that's supported on the client. The other is you really want a unified routing solution so that when you build your app, you don't need to know whether it's running on the server or not. This leads to a lot of code sharing, so upwards of maybe 90% of your code, other than the section that sets up the environment for the server-side rendering and the section that sets up the environment for the client-side rendering. Everything else can be shared. And finally, the unified data layer, which I've already mentioned should be GraphQL, or at least I'm arguing that it should be GraphQL. So universal rendering looks a lot like this. It's the difference between the server-side rendering and the client-side rendering are, or can be, trivial. In more complex applications, this can also get more complex. But for example, React has a couple of functions for rendering. One of them is render to string, one of them is render to static markup, and the other one is just render. We can basically swap those out based on where we are rendering, and our app doesn't need to know where it's rendering. And this is a list of UI frameworks that support this kind of rendering process. This is not a complete list, but it's enough to say that universal rendering is a default feature of most modern UI frameworks. And this can actually lead to even more interesting situations like using Elm or PureScript for this. So unified routing, this is a display of the React Router v4 API. And the only difference when we are rendering our app is we are using a static router on the server versus a browser router on the client. So the static router, just give a very brief summary, takes one URL and will render your app as if it was only at that URL and not care about anything else. The browser router renders in the browser, it listens to the history API if you want it to, and updates your app over time. But your app doesn't need to know about any of that. Again, one of the really nice things about code sharing is that you can generate the static site, and then you can also generate a client-side progressively enhanced bundle for your static site. So if you want things like page transitions, if you want things like dynamic actions that can happen on your static site, you now have an easy way to set up a progressive enhancement from your static site into however dynamic you want it to be. And one of the things about code sharing in Leo specifically is that you build your web app as normal, as you would expect it to just be a client-side app, and you get static rendering effectively for free. Let's take a minute to talk about URL generation. The URL generation methods in projects like Jekyll is, as I mentioned before, effectively based on where you set your markdown file in a specific directory. This works for simple use cases, but for more advanced use cases, such as the ones we're talking about, it's nice to have the content put forth primitives for building the URLs. And the nice thing about having a database of content, which has things like slugs predefined for you, is that you can post-process them into complex taxonomies and insert those URLs back in as well. So instead of relying on the framework to support taxonomies for a specific content type, you can now simply process your data and generate all of the URLs that you would need and then render them out later. A good use case of this, or a good example of this would be if you are supporting multiple versions of documentation for your project. They might live in separate branches because you're still giving support for those versions. So they're not all in the same branch, in the same repo, and you might want to go fetch them and bring them in. And again, this is sort of, when you're building your static bundle, your HTML generation is a function of the URL. So when your static bundle runs, it has the responsibility for making the request for the data that you want on that page and then rendering that out into HTML and JSON if you need it. So let's talk a little bit about low Earth orbit and how these things combine in this project to create a highly extensible, pluggable environment for any UI framework that you would want to build a static site with. Leo is a library for building static site generators, effectively. When you run a Leo project, the pipeline looks much like this. We acquire the data, which can come from files on your file system or APIs. You process the data. So after we fetch all of the data that we need, we can post-process this data to create these taxonomy pages, for example. We can bundle up our categories and our tags and our authors and make all of these pages, or make all of these URLs and extracted data. We can do things, because this is built on Webpack, we can do things like create excerpts for data. So if you have a blog post content type, you can have it process an excerpt out and then render those excerpts on your homepage. The next step is to expose this data as a GraphQL API. And the GraphQL API is our central interface to all of our data. We have to extract the URLs from that data before we render. So we extract them, we send them into the Webpack bundles. One of them is the static bundle, one of them is the client bundle. You don't necessarily need to use the client bundle, but it is there if you want it. And effectively, the static bundle is UMD Webpack's library that exposes a function that takes the URL and some locals, maybe some globals that you wanted defined all the time, the build environment or something like that, and then runs them through and produces all of your HTML. The thing that's interesting about the static bundle and having the additional client-side bundle with GraphQL is that you can fetch only the data you need in the static bundle. Leo provides a function for hooking into Webpack so you can write those JSON files out to disk with hashes. And then your client side can replace the network layer of your GraphQL client and go and fetch JSON files instead of hitting a live GraphQL API. So if you build a static site, you can effectively turn this into a progressive web app with a very, very high level of caching for all of the data that you would need to fetch. And your docs are now offline first. So the pieces of Leo are effectively Webpack. Webpack does a lot of the sort of composability and plugin functionality. There is the plugins, the Leo plugins, not Webpack-specific plugins. The data processing that we talked before, where you can generate URLs and things like that. GraphQL for the data interface. Pluggable scaffolding, which is how you get Apollo or how you get React or how you get Inferno to be the framework that you use for rendering these static sites. Content types and sources. So there's the content types, which are effectively little bits of GraphQL schema that are composed together, and then sources, which can come from, say, files, APIs, etc. And finally, we'll talk a little bit about how decoupling the editing, the rendering, and the storage of this system enables some really cool integrations. This is a quote from a Smashing Magazine article, and it is the best quote I've found to explain why Leo is built on Webpack. And the quote is, Jekyll is not meant to be included in a build process. Jekyll is meant to be the build process. And as people who work with JavaScript in a modern environment, we already have tools for module bundling, and we already have tools for data processing that work really well that are based on Webpack. We have tools that are Webpack plugins that can speed up your build or speed up your static site build by using DLLs. We can use loaders if you want to use TypeScript to generate your static site. We can use plugins like Offline Plugin to create progressive web apps. Leo plugins are pretty simple. The index will add anything to the Webpack config or allow you to add anything to the Webpack config that you would want to add if you need to. If you're processing files, you'll definitely want loaders and things like that. Leo plugins can also do things like add arbitrary other Webpack plugins, like the DLL plugin if you want to speed up your build, or if you feel like the Uglify settings are not to your liking, you can use Bibili or something like that. The process file allows you to post-process the data. So you basically get an entire copy of the database to do whatever you want with, and then you pass it back, and we continue down the plugin pipeline. The GraphQL schema segment exists in schema, and this can either be hard-coded, like for maybe a blog post or a markdown file, or, more interestingly, you can call out to contentful, introspect the content types that you have stored in a foreign CMS, use those to construct a GraphQL schema, and then offer that instead, and offer different resolvers that will call out to that API. And finally, the loader. If you want your content type or your plugin to have its own loader, you can define a loader here and use it. GraphQL is a part of this, and it enables some really interesting tooling. So, for example, you can now run Leo API, and you get a hot GraphQL endpoint where you can just start firing off graphical requests and start exploring the data that you're going to use to render the static site. You can use things like the Apollo DevTools if your scaffolding includes Apollo. So live in your sort of development build, you can play with the data that's been pulled down into your Redux store and make sure that it's getting the right data and that it looks like it should. And you can play with the data already in the store, composing new queries. And then the other thing that GraphQL allows us to do is introspect and validate queries across projects. So, for example, there's ESLint plugin GraphQL. And because we are using a composed GraphQL schema, we can get that introspection query, throw it into ESLint plugin GraphQL, and now if you are, say, an agency and you have 10 different marketing sites that all need to do basically the same content, you can validate that any new changes to your UI don't make queries that don't make sense. And then you can do things like store your content types in Contentful and do the introspection query. And because of ESLint plugin GraphQL, you can make sure that nobody changed them in a foreign system without you knowing. And then you go to render and it blocks because it's not what it expects it to be. Again, the pluggable scaffolding is how you get support for framework of choice. Leo, the project, started out with explicit support for React. And right now the main scaffolding plugin is a React/Apollo scaffolding. But you can put in anything you want here. You can put in Preact, you can put in Inferno, you can put in Vue, Angular if that's your style. And sort of everything else that coalesces around this is interesting as well. You can do progressive web apps. You can do GUIs. Because we've separated editing, storage, and rendering, you can use something like Dropbox Paper to have a collaborative editing environment. You can use that as your data source. You can then pull that down from Markdown files via the API and render it in your static site. So you have this really nice collaborative real-time editing environment that you didn't have to build, that you can use for your marketing site or your internal blog or something like that. And that's most of what I had to talk about. If you are interested in Webpack, there's a talk at 3:45, track 2. And Universal Apps, there's a talk at 4:35 in track 2. I am Chris Biscardi, and you can access the project at superawesomelabs/Leo. Feel free to open issues, ask questions, whatever you want. Thanks.